What do you know about DOK? It stands for depth of knowledge, and it's everywhere in instruction these days. We find it focusing on assessments and in our instruction, but how much do we really know about it? Depth of knowledge, a lot of times we're thinking, oh, we're going to make the problems harder, but it's actually not. So Norm Webb in 1997 came up with this framework for looking at state, national, and international tests, and it's a way of looking at the depth of thinking. So not that we're going to ask a 6 times 7 type problem and then go, oh, now we're going to ask 16 times 17 or 167 times 100. We're not making the problem more difficult. It's actually ways of thinking. So let's go into all of these. Okay, so DOK 1, depth of knowledge 1, is the first one, and it's recall. It's focusing on just retrieval of information from long-term memory. It's following an algorithm. It's like following a recipe. What are the steps? So that's the first depth of thinking. So an example would be 6 times 7. What is it? 12 times 13. You might know it's 156. You might not. It's a little bit more difficult than 6 times 7, but it's still just recall. They're both at depth of knowledge 1. Now, the depth of knowledge 2 is more interesting in mathematics than in science and literacy, at least I think so, because it really breaks into 2 different components. So we're going to call them DOK 2A and 2B. So 2A is about problem solving. It's about thinking. And typically it's in story problems, but it could also be geometric situations as well. So in this case, we might say, I have 6 rows of 7 strawberries in each row. How many strawberry plants do I have in all? So now what we're doing, it's not just retrieval, but I got to listen to the story. I got to focus on the quantities and then determine which operation I'm going to use, addition, subtraction, multiplication, or division, and then solve the problem. So it's that next level. In that same kind of area of the brain, there's also conceptual. So 2B is conceptual understanding, and that is how does something work? And that is tied to a visual representation in mathematics. So in this case, we might say something like, we're going to focus on, could you create an area model for 6 times 7 and explain the 6 rows and the 7 rows? So really it's just modeling it. How does that model work? And that gets at that understanding of the conceptual of how something works versus just the procedure. Then we get to DOK 3. DOK 3 now is justification, reasoning, communication. So now we're going to be asking questions like, oh, well, how is 6 times 7 and 7 times 6 similar and different? So now kids have to explain, maybe using an array. So go back, and this is kind of an interesting piece here. Every level that we go down subsumes the previous level. So you have to, for DOK 3, you have to do the DOK 2 and the DOK 1. That's what makes this deeper understanding of the mathematics. So here, a student may say, yes, in context, a 6 by 7, 6 rows by 7 columns looks different than 7 columns and 6 rows. So the arrays are slightly different. And now we have to say, oh, but the product, they both get 42. So yes, they're the same, but visually and in context, they're actually different. Or a lot of times with DOK 3, we also just say, one student had this explanation for understanding this type of reasoning, this mathematical situation. This student had another way of thinking about it. Which one was more efficient? Which one was correct? Which one had a mistake? So now we're comparing different arguments as well. And with this one, I've noticed a lot of textbooks, they'll end and just say, explain. That is not the right question to end with, because what happens when you say just explain, students typically say, oh, I added 4, I multiplied by 2. They do it as a procedural response. So then what we like to do is say, use the structural words. We have a research overview, we have a DMT insight on this topic, the structural language. So using the word unit, compose, decompose, iterate, partition, and equal to be able to explain why this works or does not work. That makes the explanation so much more rich. Very helpful. Then there's DOK 4. Now we don't always see this one typically in instruction or even on assessments. And it's extended thinking. And that's really taking these ideas like with multiplication, where you are going to look at patterns over time. So an example may be, we have an area of 48. And if we look at all the different factors and then look at the perimeter, what happens to the perimeter with all those different factors when we hold the area to be 48 square units? And so then they're extending their thinking, looking for patterns over time. So very powerful. So those are the 4 DOKs. Okay, now let's just talk about instruction and what's really important. So the first idea is thinking, okay, it's not about just making problems harder. We're gonna modify the question to get at this idea of retrieval, problem solving, modeling it with visual relationships, and then that extended thinking idea for patterns. Now, I like to we'll use this inverted triangle, it's just a triangle, but we'll usually say inverted, and the top part's larger, that's DOK 1, and that's gonna be about 60 to 70% of your instructional questions, and even when you look at your assessment, that too, we'll come to that back in a second. Then the next layer, that DOK 2, which includes both the problem solving and the conceptual, making sure we have both in there, is probably around 20 to 30%. And then DOK 3, asking those justification questions, because they subsume everything else, maybe 5 to 10%, maybe just one question a day. So that leads to the next piece would be an assessment matrix. And now we have another DMT insight on just the assessment matrix alone if you just want to get more details about that. But it's really important to think about, we have this frame where you're looking at your end of unit assessments and determining, like, are they typically 90% or more of the problems are just symbolic and just DOK 1. So how do we include more DOK 2A, 2B, and definitely DOK 3? Now, I've been in districts where kids aren't doing that great on DOK 3. So then teachers remove those assessment questions, but we should be thinking our instruction should follow this every day. And if our instruction includes all these different items, then our students will do this as well. So then what that does is it creates a conceptual understanding over procedural understanding. So we want kids to understand the procedures, but if they know the concepts better, then they know the procedures better. We have a DMT insight on the difference between conceptual and procedural. Check that one out as well. So this leads to just these small shifts in the way you ask these questions really develops this deeper thinking for the kids. It's absolutely incredible to be doing this. So plan accordingly. When you're thinking about your week, how am I going to include all 4 of these types? So DOK 1s, the 2A, 2B, and the 3, all these types of questions. You can just quickly modify them. So be intentional. Create the rigor in your students by asking these different questions, and you will create students that have incredible math proficiency. So please like this, share this with others if you found it very interesting, and go ahead and check out our other DMT insights. Contact us, ask questions. We are willing to have Zoom conversations, come out to your school. Our one job is to make sure that you and your students understand mathematics.